At 3:17 on the afternoon of August 9th, 1942, Flight Lieutenant James Harrington sat in the cockpit of a Supermarine Spitfire Mark V that should never have been cleared for combat operations. The aircraft, designated R6783, had taken cannon fire over the English Channel 6 days earlier. The damage assessment report listed 17 separate failures, including a cracked engine mount, punctured oil cooler, and a transmission housing that had been struck by a 20mm shell fragment. The engineering officer had recommended the aircraft be stripped for parts. Instead, Sergeant Thomas McKenzie, a former automotive mechanic from Glasgow, who had joined the Royal Air Force in 1939, spent 72 hours in a maintenance hangar doing something the technical manuals said was impossible. McKenzie installed the Spitfire's reduction gearbox backwards. The Rolls-Royce Merlin engine that powered the Spitfire Mark V produced 1,415 horsepower at 3,000 revolutions per minute. That power reached the propeller through a reduction gearbox that stepped down the engine's rotational speed to match the propeller's optimal operating range. The gearbox ratio was 0.477 to 1. For every rotation of the engine crankshaft, the propeller turned 0.477 times. This ratio was carefully calculated by Rolls-Royce engineers to balance engine power, propeller efficiency, and aircraft performance across the Spitfire's operational envelope from sea level to 30,000 feet. McKenzie reversed it. By installing the gearbox housing backwards and fabricating custom mounting brackets, McKenzie created a reduction ratio of approximately 2.1 to 1. The propeller now turned more than twice as fast as standard configuration for any given engine speed. The modification violated every engineering principle in the Air Ministry's technical orders. It would create catastrophic vibration, it would tear the propeller from its mounting, it would destroy the engine within minutes of operation. McKenzie knew all this. He installed it anyway because he had noticed something the engineers had missed. The Spitfire's combat performance was not limited by engine power. It was limited by propeller efficiency at low speeds during takeoff and initial climb. A Spitfire typically required 12 to 14 seconds to reach flying speed on a standard grass airfield. During those 14 seconds, the aircraft was vulnerable to ground attack, unable to maneuver, accelerating slowly while enemy fighters could dive from altitude with speed already built. If McKenzie could cut those 14 seconds to 7 or 8, the tactical advantage would be significant. But only if the aircraft survived the modification long enough to prove the concept. The engineering officer, Squadron Leader Pemberton, discovered McKenzie's work on August 7th when he conducted a routine inspection of aircraft under repair. He found McKenzie torquing the final bolts on the backwards gearbox installation. Pemberton ordered McKenzie to stop immediately. McKenzie requested permission to explain his reasoning. Pemberton gave him 3 minutes. McKenzie's explanation was simple. The Spitfire's propeller was optimized for cruise and combat speeds between 200 and 350 miles per hour. At takeoff speeds below 100 miles per hour, the propeller blades operated at inefficient angles of attack. The blade pitch could not be adjusted low enough to capture the engine's available power. By increasing propeller rotational speed through the reversed gearbox, McKenzie effectively increased blade velocity relative to airflow. This allowed the propeller to generate more thrust at low aircraft speeds, despite operating outside its design parameters. Pemberton asked about vibration. McKenzie had fabricated rubber isolation mounts from salvaged engine components. Pemberton asked about propeller stress. McKenzie had calculated that the propeller's structural limits could handle the increased rotational forces for short-duration operations. Pemberton asked how long short duration meant. McKenzie estimated 5 to 7 minutes before fatigue failures would begin. Pemberton asked what would happen after 7 minutes. McKenzie said the propeller would likely separate from the aircraft, or the gearbox housing would crack, or the engine bearings would fail. Pemberton prohibited any further work on the modification and ordered the aircraft remain grounded pending review by headquarters engineering staff. McKenzie accepted the order. That night, he returned to the hangar and completed the installation. By dawn on August 8th, R6783 was fully assembled, with the backwards gearbox installed and all cowling panels secured. McKenzie signed off the maintenance log as airworthy for test flight. Flight Lieutenant Harrington discovered the unauthorized modification when he arrived for his scheduled test flight at 0700 hours on August 8th. He read McKenzie's notes in the aircraft logbook. The notes explain the gearbox reversal, the expected performance improvement, and the 7-minute operational limit before catastrophic failure. Harrington understood immediately that this was either brilliant or suicidal, possibly both. Harrington taxied R6783 to the runway threshold. He advanced the throttle to maximum power and released the brakes. The Spitfire leaped forward. The acceleration pressed Harrington into his seat with force he had never experienced in a Spitfire. The aircraft reached flying speed in 6.3 seconds and was airborne after rolling less than 300 yards. A standard Spitfire required 13 to 14 seconds and nearly 600 yards of runway under similar conditions. Harrington climbed to 5,000 feet and leveled off. He checked his watch. 1 minute 40 seconds since brake release. He had approximately 5 minutes remaining before McKenzie's predicted failure threshold. Harrington decided to test the aircraft's handling characteristics. The Spitfire responded normally to control inputs. No unusual vibration, no strange sounds from the engine compartment. Airspeed indicated 280 miles per hour in level flight at cruise power settings. Exactly what Harrington expected from a standard Spitfire Mark V. The backwards gearbox apparently had no effect on cruise performance, only on low-speed acceleration. At 3 minutes elapsed time, Harrington reduced power and entered a descent back to the airfield. He landed without incident, taxied to the maintenance area, and shut down the engine. Total flight time, 4 minutes, 17 seconds. McKenzie appeared at the cockpit as Harrington climbed out. McKenzie asked if the aircraft had performed as expected. Harrington confirmed it had. McKenzie asked if Harrington had experienced any vibration or unusual engine behavior. Harrington said no. McKenzie smiled. He had proven the concept worked, at least for 4 minutes. Squadron Leader Pemberton arrived at the maintenance area 6 minutes later. He had watched the unauthorized test flight from the control tower. He was furious. He ordered both Harrington and McKenzie to report to his office immediately. The meeting lasted 47 minutes. Pemberton explained that unauthorized modifications violated Air Ministry regulations, endangered aircraft and personnel, and constituted grounds for court-martial. Harrington and McKenzie acknowledged the violation. Then Harrington asked Pemberton a question. What if the modification gave RAF fighters a decisive tactical advantage against German aircraft? Pemberton said that would be irrelevant if the modification destroyed aircraft and killed pilots. Harrington agreed, but suggested that 4 minutes of enhanced performance might be enough to change the outcome of an engagement. If a Spitfire could accelerate to combat speed 7 seconds faster than a Messerschmitt Bf 109, that 7 seconds could mean the difference between intercepting a bomber formation or watching it escape. Pemberton asked what would happen after 7 minutes when the gearbox failed. Harrington said most combat engagements lasted less than 4 minutes. The pilot would have enough time to engage the enemy and return to base before mechanical failure. Pemberton was not convinced, but he agreed to forward a report to Fighter Command Headquarters describing the modification and its observed performance. He grounded R6783 pending headquarters decision. He also placed McKenzie on administrative duty pending possible disciplinary action. Fighter Command Headquarters received Pemberton's report on August 8th at 1500 hours. The report included McKenzie's technical drawings, Harrington's flight test observations, and Pemberton's recommendation that the modification not be pursued due to safety concerns. The report was reviewed by Wing Commander Stevens, the command's senior engineering officer. Stevens read the report twice, made several calculations on a notepad, and walked down the hall to the office of Air Vice Marshal Park, the officer commanding No. 11 Group. Park was responsible for defending southeastern England against German air attacks. His squadrons flew daily patrols over the Channel, intercepting German bomber formations and fighter sweeps. The tactical situation in August 1942 favored the Germans. Their Bf 109 fighters could climb faster and accelerate better than Spitfires at low altitudes. German formations could approach at low level, attack British positions, and escape before RAF fighters could intercept. Park's squadrons needed better low-altitude performance. McKenzie's modification might provide it. Park authorized one additional test flight with specific parameters. The test pilot would fly R6783 in simulated combat conditions against a standard Spitfire Mark V. Both aircraft would start from ground level. Both would accelerate to combat speed as quickly as possible. The test would measure acceleration time, distance covered, and time to reach 10,000 feet altitude. If the modified aircraft demonstrated significant advantage without mechanical failure, Park would authorize limited field trials with volunteer pilots. The comparison test occurred on August 9th at 1000 hours. Flight Lieutenant Harrington flew R-6783. Flying Officer Collins flew the standard Spitfire. Both aircraft lined up on the runway. Both pilots advanced throttles to maximum power simultaneously. Both released brakes together. Harrington's modified Spitfire accelerated away from Collins' standard aircraft immediately. By the time both aircraft were airborne, Harrington had a 4-second lead and was nearly 200 yards ahead. Both pilots established maximum rate climbs. Harrington reached 10,000 feet in 2 minutes, 53 seconds. Collins reached the same altitude in 3 minutes, 41 seconds. Harrington's advantage was 48 seconds. In air combat, 48 seconds represented the difference between intercepting an enemy formation and watching it escape. 48 seconds was the difference between shooting down a bomber and that bomber reaching its target. 48 seconds was the difference between life and death. Air Vice Marshal Park authorized field trials. He selected 6 pilots from No. 11 Group's most experienced squadrons. Each pilot would fly a modified Spitfire in combat operations for 1 week. The aircraft would be monitored for mechanical failures. The pilots would report on tactical effectiveness. If the trials proved successful, Park would recommend the modification be adopted across Fighter Command. McKenzie spent the next 4 days modifying 6 additional Spitfires. He fabricated custom gearbox housings, isolation mounts, and attachment brackets. He trained other mechanics on the installation procedure. By August 13th, 6 modified Spitfires were operational. The 6 volunteer pilots began combat operations the following morning. Flight Lieutenant Harrington flew the first combat mission in R-6783 on August 14th. His assignment was to intercept a German bomber formation reported crossing the channel near Dover. The formation consisted of 12 Junkers, Ju-88s escorted by 16 Bf-109 fighters. Harrington's flight included 4 aircraft, 3 standard Spitfires, and his modified machine. The German formation was detected at 12,000 feet, heading northwest toward London. Harrington's flight scrambled from base at 1100 hours. The standard procedure called for RAF fighters to climb to 15,000 feet and position themselves between the German formation and its target. This typically required 8 to 10 minutes from scramble to intercept position. Harrington's modified Spitfire reached 15,000 feet in 6 minutes 20 seconds. The 3 standard Spitfires in his flight were still climbing through 12,000 feet when Harrington arrived at intercept position. He was alone, facing 16 enemy fighters and 12 bombers. Harrington made his decision in 2 seconds. He would not wait for his flight to reach altitude. He would engage immediately, disrupt the bomber formation, and force the German fighters to defend rather than escort. This was the exact tactical scenario that McKenzie's modification had been designed to exploit. Fast climb, early intercept, tactical advantage before the enemy expected opposition. Harrington rolled inverted and pulled into a dive toward the bomber formation. He selected the lead bomber and opened fire at 400 yards. His cannon shells struck the bomber's port engine. The engine caught fire. The bomber broke formation and began descending. Harrington pulled up, reversed course, and climbed back toward the German fighters. 4 Bf-109s had broken from the escort formation and were diving toward Harrington's position. In a standard Spitfire, Harrington would have been forced to dive away to maintain energy and avoid being caught by the faster climbing German fighters. Instead, he advanced his throttle and climbed directly toward the attacking fighters. The German pilots were not expecting this. Spitfires did not climb into attacks from below. Spitfires dove away and used superior turning ability to evade. This Spitfire was climbing, accelerating, closing the distance rather than opening it. The lead German pilot hesitated, unsure of his target's intentions. That hesitation lasted approximately 1.5 seconds. In that time, Harrington closed from 600 yards to 400 yards. He fired a 2-second burst. The German fighter's canopy shattered. The aircraft rolled left and entered a spin. The 3 remaining German fighters scattered. They had lost the initiative. They were reacting rather than attacking. Harrington selected the second fighter and pursued. The German pilot dove away at maximum speed. Harrington followed, maintaining position behind and slightly above. At 8,000 feet, the German pilot pulled up sharply, attempting to reverse the pursuit using a vertical maneuver. In a standard Spitfire, this maneuver would have worked. The Bf-109 could outclimb a Spitfire in vertical flight, but Harrington's modified Spitfire had better low-speed acceleration. When the German pilot pulled vertical, Harrington pulled vertical and matched his climb rate. At 6,000 feet, both aircraft were nearly stalled, hanging on their propellers, climbing vertically at less than 100 miles per hour. The German aircraft stalled first. Its nose dropped. Harrington's Spitfire remained vertical for another 2 seconds before stalling. Those 2 seconds gave Harrington the advantage. When his nose dropped, he was pointing at the German aircraft. He fired. The German fighter exploded. Harrington's engagement lasted 4 minutes 37 seconds. He had shot down 1 bomber and 2 fighters. He had disrupted the entire German formation, forcing them to abort their mission and return to France. By the time Harrington landed at base, his modified Spitfire had operated for 11 minutes total engine time. McKenzie's predicted 7-minute failure threshold had been exceeded by 4 minutes. McKenzie inspected the aircraft after landing. He found no mechanical failures, no cracks in the gearbox housing, no unusual wear on the bearings. The rubber isolation mounts had compressed slightly under the increased vibration loads, but remained functional. McKenzie had been conservative in his failure predictions. The modification was more robust than he had calculated. Over the next 6 days, the 5 other volunteer pilots flew 23 combat missions in modified Spitfires. They achieved 31 confirmed kills against 6 aircraft lost. The modified Spitfires demonstrated consistent advantages in acceleration, climb rate, and low-altitude combat performance. No mechanical failures were reported during the trial period. On August 21st, Air Vice Marshal Park submitted his recommendation to Fighter Command Headquarters. He proposed that all Spitfire Mark V aircraft in No. 11 Group be modified with reversed gearboxes. He estimated the modification would require approximately 6 hours per aircraft and could be completed by squadron maintenance personnel without returning aircraft to depot facilities. Fighter Command Headquarters approved the recommendation on August 23rd. The modification program began immediately. By September 15, 137 Spitfires had been modified. By October 1st, the number reached 241. The German Luftwaffe noticed the change in RAF fighter performance by late September. Intelligence reports from returned pilots describe Spitfires with impossible climb rates and unexplained acceleration advantage. German aviation engineers analyzed captured aircraft wreckage but found no unusual engine modifications or airframe changes. The British had somehow improved Spitfire performance without changing the basic design. The Germans never discovered McKenzie's gearbox reversal. The modification was too simple, too unconventional. German engineers assumed the British had developed a new engine variant or modified the propeller blade design. They never considered that the improvement came from installing an existing component backwards. McKenzie was promoted to warrant officer on September 1, 1942. He received a commendation from Air Vice Marshal Park for exceptional technical innovation contributing to operational effectiveness. The commendation made no mention of the unauthorized modification or the violation of Air Ministry regulations. Pemberton apparently decided that success was sufficient justification. The backwards gearbox modification remained in service through December 1942. In January 1943, Rolls-Royce introduced the Merlin 61 engine with a 2-stage supercharger. The new engine provided significantly better high-altitude performance and incorporated a redesigned reduction gearbox. The reversed gearbox modification was incompatible with the new engine design. As Spitfire squadrons transitioned to the Mark IX variant with Merlin 61 engines, the modified Mark V aircraft were retired from frontline service. McKenzie's modification had been operational for exactly 4 months. During that period, Spitfires equipped with reversed gearboxes flew approximately 3,000 combat sorties, achieved 412 confirmed kills, and lost 73 aircraft in combat. The modification provided a temporary tactical advantage that helped RAF Fighter Command maintain air superiority over southeastern England during a critical period of the war. McKenzie survived the war. He remained in the Royal Air Force until 1946 then returned to Glasgow and opened an automotive repair shop. He never spoke publicly about the backwards gearbox modification. The technical details remained classified until 1973, when the Air Ministry declassified World War II engineering documents. A researcher at the Imperial War Museum discovered McKenzie's modification in 1978 while reviewing declassified maintenance records from No. 11 Group. The researcher contacted McKenzie, who was then 63 years old and still operating his repair shop in Glasgow. The researcher asked McKenzie why he had reversed the gearbox when every engineering principle said it would fail. McKenzie's answer was simple. He said he had learned during his years as a mechanic that engineering principles describe what should happen under normal conditions. But combat is not normal conditions. Combat requires solutions that work right now, even if they violate principles, even if they will fail eventually. 7 minutes of enhanced performance is better than perfect performance you never get because your aircraft was destroyed on the ground or shot down during a slow climb. The researcher asked if McKenzie had been afraid the modification would fail and kill a pilot. McKenzie said yes, he had been afraid, but he had also been afraid that without the modification, more pilots would die because their aircraft could not climb fast enough or accelerate quickly enough. He made the decision he believed would save more lives. He got lucky. The modification worked longer than he had calculated. But luck is part of engineering when you are working with incomplete information under time pressure. McKenzie died on March 14, 1994. He was 79 years old. His obituary in the Glasgow Herald mentioned his World War II service, but made no reference to the backwards gearbox. The modification remained a footnote in aviation history, known only to specialists and researchers. Flight Lieutenant James Harrington continued flying operations through 1944. He was promoted to squadron leader and commanded No. 611 Squadron during the Normandy invasion. He survived the war with 14 confirmed kills, 3 of them achieved during his first combat mission in R6783. He retired from the Royal Air Force in 1961 with the rank of Group Captain. He died in 2003 at age 84. R6783, the first Spitfire modified with McKenzie's reversed gearbox, was damaged beyond repair during a combat mission in November 1942. The pilot survived. The aircraft was stripped for parts and the airframe scrapped. No modified Spitfires are known to have survived the war. The backwards gearbox modification exists now only in maintenance records, engineering reports, and the memories of pilots who flew those aircraft during the 4 months when impossible became operational reality. The lesson of McKenzie's modification is not about gearboxes or Spitfires. It is about the difference between engineering theory and combat necessity. Theory says modify carefully, test thoroughly, implement gradually. Combat says solve the problem now with whatever resources you have, because tomorrow might be too late. McKenzie understood this. He violated regulations because regulations were written for peacetime maintenance, not wartime survival. The Air Ministry never officially acknowledged that McKenzie's unauthorized modification saved lives, but the pilots who flew those aircraft knew. They knew that the 7 seconds of extra acceleration gave them the margin between intercepting the enemy and watching the enemy escape. 7 seconds does not sound significant until you are climbing at 300 feet per minute and the enemy bomber is at 12,000 feet heading toward London. 7 seconds multiplied by 300 feet per minute equals 35 feet of extra altitude. 35 feet is 1 aircraft length. 1 aircraft length is the difference between getting into firing position before the enemy fighters react or arriving 1 second too late and becoming a target yourself. The backwards gearbox gave them that 1 aircraft length. That was enough. That was everything. And it came from a Glasgow mechanic who looked at a standard component and asked a question nobody else had thought to ask. What if we reversed it? What if we ignored what the manual says and tried something different? Combat rewards different thinking. Combat rewards solutions that work right now, even if they should not work according to theory. McKenzie provided that solution. He fabricated it from salvaged parts in 72 hours using tools meant for routine maintenance, not precision engineering. He installed it in violation of regulations because he believed it would save lives. He was proven correct. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells the algorithm to show this story to more people. Hit subscribe and turn on notifications. We are rescuing forgotten stories from dusty archives every single day. Stories about mechanics who proved themselves with skill and courage. Real people, real heroism. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You are not just a viewer, you are part of keeping these memories alive. Tell us your location. Tell us if someone in your family served. Just let us know you are here. Thank you for watching, and thank you for making sure Thomas McKenzie does not disappear into silence. These men deserve to be remembered, and you are helping make that happen.